last 60 years. Obviously, there's the argument, well, we live a lot longer, and I'm arguing, well, that's previous generation. We don't know how long our generation is going to last, or what's going to happen to us even if we continue to live. Well, there's changes in birth deformities, reproductive difficulties, neurological abnormalities, cancers of certain types, cardiorespiratory morbidity and mortality, even though we're better at resuscitating people. If you have a heart attack, you can have a stent put in. All the things that we can do to repair acute damage in these diseases has improved. However, the numbers are still going up. Asthma increased. When I was a little kid, if you were a child with asthma, you were kind of a weird little mama's boy, and there weren't very many around. Now go to the schools, it's 15–20% of the kids have their inhalers in the school office. Obesity and diabetes, one can argue successfully that's related to lifestyle. We're fat and we don't exercise. But along with that, there's a relationship with environmental pollution, which I'll show you. There's emerging conditions, sick building syndrome. Didn't teach me that in medical school in the 60s. Environmental sensitivities, chronic fatigue syndrome, fibromyalgia. So when we look at outdoor air, La Régie or OHIP in Ontario, accurate statistics, who goes to the hospital. All you have to do is plug in the computer and you've got those statistics. Hospital visits, emergency room visits. When you get into physician office visits, because there are enough physicians and everybody's booked, if you get sick, you may not get in for 2 or 3 days or even a week. So as we go down that pyramid, the statistics become a little less easily available and more harder to dig out. The point of this is that we know that there are days when the air is bad outside, when the air is good outside, and they've been monitoring it for a while. And when you look at the bad air days, you're going to see more mortality, more hospital admission, more emergency room visits, and so on, associated with outdoor air quality. Conditions impacted directly by outdoor air, asthma, makes sense. The air sucks and you've got irritable lungs, it's going to be aggravated. Allergies. Again, when I was a little kid growing up, I remember going to summer camp, and there was always a kid or two in the summer camp who had horrible allergies, who didn't last, and he had to be sent back into the city because of the grass pollens and the weed pollens and the ragweed and so on. It was too much outdoors in the countryside, so you had to go into the city. It's not the same anymore. Allergies are worse in urban areas than they are in rural areas now because of the impact of the environment. Chronic obstructive pulmonary disease. You got bad lungs, you got irritable lungs. Obviously, air quality is going to have a negative effect. Where'd this come from? Cardiovascular disease. These are the people that are going to the morgue, and these are the people that are going to the emergency room and the intensive care unit on the bad air days. There's more heart attacks, more arrhythmias, and more sudden death. What are the major outdoor pollutants? Ozone and particulate matter. And you'll notice as I pop a few more up there, they don't have the asterisks because these two, ozone and particulate matter, are the things that the statisticians and the scientists are looking at outdoor air effects on health. The literature is very, very strong that there's an association with these two things and the patterns of illness. Nitrous oxides, sulfur oxides, carbon monoxide from cars. It's really, it's there. It's certainly going to be a lot worse if you leave the car on in the garage with the door closed. Lead has gone down a significant amount, a very significant amount in the outdoor air since they stopped using lead additives. Volatile organic compounds. Now this does not mean there's no pesticides. The term organic in chemistry means that it's a group of chemicals that have a whole bunch of carbon atoms in them as part of the skeleton of the molecule. So when they're talking about organic and inorganic compounds in chemistry, they're talking about whether there's a bunch of carbon atoms or not. But volatile organic compounds, volatile means they tend to vaporize, they tend to become gaseous and add to the air quality. The effects of all these things, the statisticians have ways of isolating things like ozone or particulate matter from the others to see whether or not they are culprits. But the effects of all of these things are probably influenced by the fact that it's a mixture. So the influence, again, could be additive, could be synergistic, like multiplying each other, or it could actually be antagonistic. Maybe one actually negates the other. Don't know. We just know that there's a chemical soup out there. So ground level ozone. So ozone is decreasing in the upper atmosphere. We all hear about the holes up there. It's supposed to be up there because it's supposed to protect us from all the ultraviolet rays, and since it's not doing a very good job anymore, we no longer go outside the tan because we can get skin cancers like melanoma. But it's actually increasing, especially in urban areas, at nose level. We're breathing this stuff now. And so where does it come from? It comes from these nitrous oxides and these volatile organic compounds, and you need a little heat and it's perhaps some of the other rays from sunlight, and that makes ground level ozone. And this is why we have more now, because we have those pollutants. If you take the ozone and you add it to some of the particulate matter, then you can see it. We call it smog. That's when the air is yellow or grayish, brownish, beigeish. Isn't it strange when you look outside at the sky and the sun is shining and you can see your shadow, but you can hardly tell the difference between the color of the sky and the cloud? What is that stuff? Particulate matter? Particulate matter, heterogeneous, fancy word, means there's a whole bunch of different things in there. So it's all different kinds of things that create this particulate matter. The main source of it, the byproducts of combustion, are in there's three categories, and it's basically on size: coarse, fine, and ultrafine, and they're microns, and I'll show you what that is in a second. Ultrafine are so small that they do not just get absorbed into the body, they can get inside cells. Somewhere up there is the head of a pin, 50 microns. If your eyes are really, really good, that's the limit of human vision. And you see when you get down to cell size, 10 particulate matter, 10 microns, that particulate matter, PM10, is what they first started looking at when they first started studying particulate matter and pollution. They said, wow, there seems to be a difference. But then they got down to the smaller size, and most of the studies are looking at 2.5. So the size of the matter at 10 microns, it gets trapped in our nose, it gets trapped in the upper airways, so it can give you congestion, but the mucus and the little hairs and the cilia capture those things to protect the lungs. The fine ones, that 2.5, they get down deeper into the lungs and onto the membranes, and they start to cause inflammation and damage. And the ultrafine particles especially do so, plus they can get absorbed. So, where do you live? There's this thing called regional prevailing winds. And this is, these arrows are going across Michigan and Ohio. Major air polluters for coal burning. And a lot of that stuff ends up going over the Great Lakes, moving up the Great Lakes system and the St. Lawrence system. A lot of stuff ends up here too. So where you live makes a difference to the air quality. It's industry, there's traffic, there's other fossil fuel use for heating and cooling our homes coming up the chimney. Temperature inversions, hot air rises. But if there's a mass of hot air that happens to slide over a cooler air mass, then the cooler air mass gets trapped underneath it and it doesn't rise. So when that happens, whatever pollution is being slowly added into the air at that level gets trapped. So the pollution level goes up when there's what's called a temperature inversion. Literally, it's just trapped for a while. And of course, temperature makes a difference to the production of ozone and smog. So you'll see more in the summer than in the winter. Volatile organic compounds. In chemistry, as I mentioned to you, organic means it contains carbon. Many of them are human-made chemicals. They're used and produced in the manufacture of all kinds of things that many of you are probably sensitive to. Paints, adhesive, glues, petroleum products. They're in medications, they're in refrigerants, and they're often compounds of things like fuel, solvents, hydraulic fluid, paint thinners, dry cleaning agents, things that are commonly used in urban settings. Windsor-Quebec corridor, one of the two most polluted areas in the country. The other one is in the Fraser Valley. And you can see the red is the hot stop for volatile organic compounds. Toronto, there's a lot. Ottawa's not bad. Montreal, again, there's a lot. Quebec's a lot. It's just to give you an idea of how this stuff gathers and, of course, how it's going to contribute in those areas to the production of ozone. Would you like to live here? It's a nice little place. It's kind of cute. Look at that, because that's the other side of this, the 401. It's a sound barrier. So those people in those nice little homes live right next to the 401. So this is a view from the 401 in the Don Valley Parkway. I don't have any pictures, unfortunately, of Montreal and DeCarry and all the neat places you have here, but I found these things on the internet, so I stole them for this lecture. Just to give you an idea, because if you're a doctor and probably most of you aren't, and you're taking a history. Do you know where your patients live? And ma'am, how many of them live here? There was a study done in the Lancet, actually it was done in Holland, so about 9 years ago. They followed 5,000 people for 8 years who were like my age, 55 to 69, living near a major road, and they had double the risk for death from cardiopulmonary diseases. So the various studies that are out there look if you're 100 meters or 300 meters, and again, because you need a control group, you get people who are really far away. And it doesn't mean that if you live 301 meters from a major route, you're okay. It's just showing you that closer has a different exposure than further. And what did they find? Preterm births, in other words, not lasting a full 40 weeks, allergies, asthma, respiratory infections, cardiovascular function has changed, and a possibility debatable at this point with the statistics of whether there's increased risk for leukemia. So what's a major road? I had to look, what's a major road? So I looked it up and said, 10,000 vehicles for 24 hours. I haven't got a clue. Whoever stands out there and counts cars unless you got that job in your university days. So I looked it up. The 401, it amazed me, is the most busy highway in North America. I didn't know that. 400,000 cars per day. So I couldn't find things from Montreal on the internet, but I found these. Yonge Street, 51,000 cars if you're ever downtown Toronto. How about Bay Street? 26,000 cars. I wonder how many cars go by Yonge and Bay. So there's this thing called the Air Quality Health Index, and I bring this to your attention because if you go into any of the weather networks for any place you're going, you want to see what the weather's like, you can actually look up the air quality. It's called an Air Quality Index, and they'll tell you, oh, it's a bad day because the ozone's high. We really don't know what a bad day exactly is. So Canada is the first to start a pilot study called the Air Quality Health Index, and if you want to check the Air Quality Health Index for Montreal, you actually have to Google Air Quality Health Index and not go to a weather channel. And you'll get a graph like this. Obviously, low risk and high risk is based on numbers, but it's based on when those bad air days are occurring. Are you more likely to have to go to the hospital or the morgue on that day? So it's a scale designed to help understand what the air quality means to health. It looks at the mixture. It shows the relative health risk with the total air pollution. And of course, the higher the number, the more likely people are going to be associating with symptoms. But it may not include people who have environmental sensitivity. It warns people with cardiovascular and respiratory complaints to reduce outdoor activities and or stay indoors. So let's look at this. Stay indoors. Maybe it's out of the fire into the frying pan, or if not, it's the other way around. Out of the frying pan and into the fire, as the expression goes. 90% of our time is spent indoors. It's influenced, obviously, by the outdoor air quality. Where's your house? The building envelope filters and reduces exposure to particulate matter, ozone, and other gases. The logic is you're better off indoors on a bad air day. However, since the energy crisis in the 1970s led to tighter buildings, yeah, the envelope keeps stuff out, but ventilation has also been reduced. The economics since the 70s have led to the development of cheaper manufactured building materials, which chemically off-gas, so we're getting more chemicals indoors. We also have more chemical cleaners, detergents, fragrances, etc. And so the indoor air quality is different. So what is good indoor air quality? It's defined as the extent to which human requirements are met. What is that? Does that mean if there's enough oxygen, it's okay? There is no consensus definition of what is good indoor air quality. So they have this term, acceptable indoor air quality. And this is what it is. It doesn't contain harmful concentration of contaminants. We don't know what the measurements should be. At least 80% of the building occupants don't express dissatisfaction, then the air is okay. So if 19% of us are complaining here, it's pretty good. So indoor air is 40 times worse than outdoor air. We have higher volatile organic compound levels indoors and outdoors. There's anywhere from 30 to 100 in a typical building. There's over 900 have been identified of volatile and semi-volatile organic compounds. Semi-volatile obviously is not as volatile as volatile. There are few health-based guidelines for volatile organic concentrations in the non-industrial indoor environment. Semi-volatile organic compounds are much higher indoors. They're the things like the fire retardants and the stain repellents. Particulate matter indoors is lower than outdoors, but it's different. Outdoor air and indoor